Now, it's always good to be the third speaker or fourth speaker because a lot of introduction have already been given, so I can accelerate going through those. I would like to talk about the Möbius technology, the dissolution technology, but I give a first insight in what TNO is doing, and the different approaches that we take, and to get, at the end come to conclusions. TNO is a research organization from the Netherlands. We work in a lot of different fields, all oriented at introducing new technologies, new methodologies and systems into the market to help society to become more sustainable. So we do that working together with industry, but also with academia, to create innovations, to bring it into the market, and to get real sustainable business competitiveness. So that's quite challenging nowadays, certainly with recycling technologies. This is a typical picture that you see on circularity everywhere, but it gives you a flavor on where we work around. So you see, I hope it's, no, you see there we work on a lot of different recycling technologies. That's why we're here today. But a large part on circularity is oriented at sustainability from the early phase. So designing products, molecules from a sustainable source like biomass, like CO2, using electricity or other sustainable energy. From there you go into the design for circularity to be able to design products in such a way that they use minimal amount of material, but also at the end of life that they can be used, reused or recycled very easily, without all the impact that already been mentioned before. So after you have achieved those, then keep it as long as possible in the value chain, and at the end, when there's really no other use of it, then you can go to the recycling technologies. After sorting, pre-treatment, and then the recycling technologies itself. And I think that's a large part which also needs to be considered, that for a lot of different recycling technologies, the sorting and the pre-treatment of the waste is quite important. Because for some technologies you need a relatively pure material, so you lose a lot of, let's say, other waste into the value chain that cannot be used or needs to be used another way. Quite important to consider the overall impact like ICA and so on. Now you have seen this picture in other ways before. The only message I want to give, let's say the ones with the extra brackets, the orange brackets, these are dealt with by TNO, either with current technologies to improve them, or to new technologies that they can become introduced into the market by accompanying with different partners. So you see it, let's say, from the incineration, the gasification, pyrolysis, solvolysis, enzymolysis, dissolution, and the mechanical recycling. So all these aspects we work in different ways, but need to be paid attention to that we don't commercialize the technologies, we do that together with partners in the field. When we do technology development, in line with the previous speakers, it's not only about the technology, it's about the whole techno-economic assessment, the market analysis, what kind of value does it bring, what does it cost, but also, let's say, what's the impact related to that. So the impact like CO2, material usage, and those kind of things. And when we do the technology development, it is, including all these assessments as well. Now, when we come to the dissolution, there's the physical recycling of the products, as already been mentioned before. And the way we do it is very simplistic. You have a polymer or a blend of polymers containing additives, containing contaminants coming from waste. By applying the Möbius technology, you are able to separate it into pure polymers that can be recompounded again, and you collect also the additives. And we try to get the additives as pure as possible as well, that you can materialize on those. The typical thing of the Möbius technology is that we use a single solvent. So a lot of other dissolution technologies use an anti-solvent to precipitate the polymer out of the material. We try to use it as much as possible with a single solvent, because then also the solvent can be recycled very easily and you can reuse it. The other one is we use low boiling solvent. Low boiling solvent because then it's easy to handle, for example in viscosity, but also easy to remove from the final product. At this moment, we are aiming for plants together with the partners for about 20 kilotons, and when it's possible, they are scalable, and then you can integrate it with your plant. One part of the dissolution technology is, of course, to dissolve the polymer itself. An important part is all the separation technologies behind it. So to be able to selectively extract the contaminants, the additives from the polymer to get the pure polymer on the one hand, but also to get the additives back again. Now I will show you a few scales that we work on and then a few projects that we work in just to give an indication what's possible, and then I will conclude some with the general remarks. Now here you see the different scales. We started, of course, on a very small scale, the 1 gram scale, to really screen very fast whether the process is suitable. And nowadays we have a semi-continuous TRL 5-6 pilot plant where we're able to produce large amounts of materials, but also to recycle the solvent, to recover the additives and so on. We have identified 3 main cases just to give an indication on what's possible, and I will elaborate on those. So one is on non-durable plastics, the other one's on durable plastics, both the WE plastics from electronics and the other one on the polycarbonate blends from different applications. Now the first one is in a Dutch consortium, mainly focused on polyolefins, where we were able to separate from multi-layer packaging the polyolefins itself, but also, let's say, being able to recover the aluminum that's coming from that. Now you see here right at the top, you see the waste products, and at the end you see the relatively pure material that you get out of it. As a result of that collaboration that we have started now collaborating with Braskem, a Portuguese polyolefin producer, to be able to recover the polyolefin from mixed household waste. So that's a final concept. There will be a demo plant, likely in Brazil, maybe in the Netherlands, that will be able to produce this material at the end of the collaboration. Another project we have been focusing on was Plus to be Cleaned, a collaboration between a lot of European parties. You see them at the red type top, where we were able to separate ABS from WE plastic, so electronics and so on, and to convert it back into an appliance with, for example, for a machine door, a wash machine door application. Now you see there, we are able to recover, of course, the ABS, but on the other hand, also to be able to remove flame retardants and titanium dioxide from the material. Quite a good achievement, and we are now busy with scaling that up. And the last example I would like to give is on polycarbonate recycling. Also there we started with WE plastics and then be able to recover the polycarbonate and to put it back into materials again. And that was mainly focused on being able to extract the electronics out of it, but also some other additives which are typically applied in WE plastics. Coming to the final conclusions on general recycling. In general, to be able to assess what is the best technology to be applied for a certain waste stream, to look at it from a system perspective, because you have next to the stream that you can recycle, you have also a stream which is a result from the sorting and washing. So you need to have an overall perspective to see, okay, how do you treat the overall streams? It might be better in some cases not to separate at all, but you put it into, for example, chemical recycling. In other cases, you need to be able first to do a lot of different sorting and washing before you enter into a recycling process. So that's really need to be assessed case by case. Now, of course, as mentioned already many times, try to minimize the use of plastic in general. So before you go into the use phase even, consider whether you really need to have the plastics, to what amount and what kind of application. And also, the type of plastic that you use, is that the one which is suited for recycling of other end-of-use application. Mechanical recycling, where the quality allows, use it. And then advanced recycling, it is a necessary element. It has been mentioned already many times. It's an essential element to be able to recover all the plastics which is in use nowadays. And then the type of recycling, that's the perspective based on the quality of the waste, the target quality of the product that you want to get out of it, and the materials that are in it, like the contaminants, the additives, and so on. So really, that's an overall perspective. What does it cost? What is the impact of it on environmental, and what is the material recovery? And then you can come into all kinds of different recycling technologies. And then dissolution is one of the gaps, or one of the possibilities to cover the gap on recovering all the materials. And I think that's where I want to end today. Thank you very much.